right. Hey, everybody. So I'm going to give you some hints on the 3.5.3 TST test for second semester. I'm going to omit a lot of questions, okay? So follow along closely. 1A, all of these are found in 3.1.1, page 15. B, you kind of have to use your own brain power, okay? So think about the definition of convection. It's when gases and liquids are moving. So think about what an oven would need in it to get the air in the oven moving around, okay? Think about what that oven would need in it. And then C, use 3.1.1, page 9. Then question 2A, look at 3.2.1, page 7. For B, look at 3.2.1, page 9. And I want you to describe when you add heat to a water sample, how does the temperature change within a phase? That means if you're heating up liquid water, how does the temperature change while it's a liquid, okay? Or if you're adding heat to water vapor, how does it change while it's a vapor? Within each phase, what happens to the temperature? And then during a phase change, what happens to the temperature? During the melting process or during the boiling process. And then for part C, I want you to omit all of question 2, part C. So omit all of those. Question 3A, I want you to omit that as well as 3B, 3C, and 4A. They didn't give you the enthalpies of formation that you would even need to do A, so you don't have to do that. For 4B, this is a Hess's law problem where we're going to manipulate these equations to get them to add up to this overall equation, okay? So I can kind of see that here the CO gas is after the arrow, but notice in my overall equation the CO gas is before the arrow. So I'm going to flip that around to CO gas yields C solid plus 1/2 O2 gas. And when I flip it around, I'm going to change the sign, okay, from a negative to a positive. So what used to be an exothermic reaction, when I flip it, becomes an endothermic reaction. For this second one, notice how CH4 gas is a product, and we need CH4 gas to be a product in our overall equation. Okay, so I'm going to keep this one the same. I'm going to have C and 2H2 before the arrow, and then CH4 gas after the arrow. And then this last one, notice how I need H2O gas to be after the arrow up here, and this has H2O gas after the arrow. So I'm going to leave that one as it is as well. And then before the arrow, we have H2 gas plus 1/2 O2 gas, like that. Okay, so what we're going to do is we're going to add these three equations together, and it's going to give us our overall equation, okay? And if anything appears both before and after the arrow, if it's after the arrow in one equation but before the arrow in another equation, it cancels out, okay? So that's before and after, and the 1/2 O2 can cancel out as well. Okay, so let's add together what we have left. We have CO, gas, and then we have 2H2 plus another H2, which is 3H2. Gas, and notice that's what we need for the overall equation before the arrow. And then after the arrow, we have CH4 gas plus H2O gas, okay? And because we can add these three equations together to get our overall equation, we can add these three together to get our overall equation. So positive 110.5, because we flipped that one, plus negative 74.85, plus negative 241.83. And that will be your overall delta H for the reaction. All right, question C. The first one, you look at 3.2.1, page 20. The second one you can omit, and the third one you can omit. Question 5A and B, you can look at 3.3.1, page 8 and 9. And B, you can look at 3.3.1, page 13. And then question 6A, the equation that you need to solve this is on 3.3.3, page 5, okay? This is the temperature, so you plug this in for T, you plug this in for delta H, and you plug this in for delta S, okay? And then The way you can tell if it's spontaneous, they tell you on 3.3.3, page 6, how you can tell from your answer if it's spontaneous or not. And then all of this stuff you can omit, okay? So question 2B, 2C, 2D, or no, sorry, not 2, sorry, question 6B you can omit, 6C you can omit, and 6D you can omit. And that's it. Okay, so those are my hints for the 3.5.3 test for second semester.